solar and wind have places in the world. They are needed, distributed, first solar, first energy, end of mile, even some industrial scale things. Nuclear has a remarkable role to play. So does methane, natural gas, and hydrogen. These things partner together for reliable, affordable energy. That's the hopeful thing. Let's not say it's either that or that. Here's the place for both. They make the system better. And when I have a healthier system, my economy runs better. And guess what? I have money to invest in the environment. And this is the kicker. It goes in that order. Energy, economy, environment. Do it again. Energy, healthy economy, invest in the environment. It goes in that order. The worst environments on the planet are where it's poor. They simply can't afford to clean it up.
Just because the facts are A, if the narrative is B and everyone believes the narrative, then B is what matters. But it's our job in our industry to speak up proudly, soberly, and to engage people in this dialogue. Those 2.5 billion people that are in energy poverty, they need us.
America cannot meet this threat alone.
If there is a single country,
of course, the world cannot meet it without America.
that is willing to
But we're going to need you, the next generation, to finish the
overhaul
job.
nuclear regulation
We need scientists to design new
and
fuels.
focus on net public
We need
benefit
engineers to invent new technologies. We
over absurd levels of radiation
need
protection,
entrepreneurs to sell those
then
technologies.
we will march towards this.
We need workers to operate assembly lines that hum with high-tech, zero-carbon
We have
components.
unlimited prosperity for all humans.
We need diplomats and businessmen and women and Peace Corps volunteers to help developing nations skip past the dirty phase of development and transition to sustainable sources of energy. In other words, we need you.
Yeah, nuclear is the talk of the town now, which is good.
Today we've got Dr. Scott Tinker. Very excited to chat with you again, Scott. We interviewed you once for the Young Professionals in Energy podcast, and we're going to chat with you again today. So Scott is the state geologist in Texas, and he's the lead of the Bureau of Economic Geology at UT Austin, and as well as the chairman of Switch Energy Alliance, which is a nonprofit that focuses on an energy-educated future. Did I get that right, Scott?
Inspiring an energy-educated future.
Inspiring it, yes.
Yes,
Sorry,
the inspiring part. And you
I
had
love
the
your
Bureau
guys'
part,
tagline.
right? Actually, the Bureau of
Yes.
Economic Geology. So,
Yeah.
the oldest research unit at UT,
Excellent.
1909. And there's only been 8 directors since 1909, 8 directors.
Wow, so long tenures.
They can't get rid of us, you know, like
They're
living
like,
fossils.
You guys move in geologic time, right? Yeah.
That's right. We are living fossils.
So Scott, for folks not familiar with Switch and Switch Energy Alliance, why don't you kind of give a little bit of background for folks? I know, we interviewed you previously, but it'd be helpful for folks that missed that one.
Yeah, Switch Energy Alliance is, as you said, a 501c3. It's a film-based entity. We make documentary films, feature-length films, but also a lot of short format stuff, and it expanded from there. So we have a classroom offering now called Switch Classroom, released during COVID, and we've got 60,000 students across the country, and 6,000 or 7,000 teachers are already using it for AP Environmental Sciences. It's free to them. It's wonderful, film-based, and teachers help with the curriculum. We've got a case competition on campuses around the world for energy poverty, big prize money, and it's just fun to see all the kids working through energy for real. They have to pick a country that we give them and help lift them from energy poverty, and it can't be fairy dust. They have to look at the economics. They have to look at the resources that are actually available in the governmental system. It's phenomenal. And we have 200 volunteer judges for that. I'd say that to your audiences. If anybody wants to volunteer, it's a remarkable experience to judge or mentor a team. We've got museum films, and our latest offering, Mark, is the PBS talk show, called an energy and climate talk show that I host called Energy Switch. 2 guests on each episode, really high-level people, the highest level, but they don't agree on everything, and we have civil dialogue around it. 25 minutes. World Channel picked us up. We're now in 100 million households, more than 80% of the PBS stations nationwide. Just finished recording season 3. So that's what we do. We really try to inspire energy educated future, and that means kind of helping everybody raise their energy IQ just a little bit.
It's fantastic. I think all of your guys' content is phenomenal. I've yet to watch or consume something that you guys have put out that I haven't enjoyed. Meaning, I think it's really high quality. It's thought provoking, and so I really appreciate all the work that you guys are doing. You had your other film, Switch On, which did a showing of here in Denver. At a theater, had a bunch of people come out. We did a little happy hour beforehand, industry folks and non-industry folks, and so that's free for anyone to do, right? You guys make that content available for folks, and had a viewing of it and then a little discussion before and after. It was really awesome.
Yeah, I think we were one of the really early groups out there on energy poverty. We started filming in 18, 19, somewhere in there, released it in 20.
Yeah.
And yeah, it's a global look at some of the scene for the 6 billion people,
Sure.
3/4 of the planet who don't have the kind of energy security that we have. And it doesn't mean you're living in the dirt cooking with dung. It does for some, but not people. What people didn't realize is how insecure energy is to a whole lot of the world. Not reliable, not affordable.
Absolutely. While we're on that film, something that struck me, one of the projects that you guys did was taking a solar light installation to a small village, and you highlight and call attention to it in the film, but just how much energy it took to get those materials and those products to that village and then set it up, and all the work that it took, which I found to be not necessarily ironic, but just thought provoking that, to have a small system installed, it took a lot of energy to get all of it there.
Oh, it's incredible. Yeah, that's why life cycle analysis is so important. And it's hard at the Bureau, my day job, as director of this big research unit, 250 people here working all over the world. We're doing something called comparing electricity options. And we're actually doing a rigorous look at solar with batteries, wind with batteries, and natural gas to begin on their environmental impacts from cradle to grave, from mining or drilling all the way through to manufacturing, processing, and burning, or blowing and shining with batteries, and then dumping CO2 into the atmosphere, or dumping batteries, panels, and turbines into landfills. So what are the true environmental impacts of that life cycle? It's very hard to do, Mark. It's rigorous. And then we are also looking at the full cycle costs of that. What's the actual cost to the consumer for that electron? You hear about LCOE, the levelized cost of electricity or energy, which is an interesting measure that is being used to compare things, but unfortunately it's incomplete. It compares the cost at the plant gate, or the bus bar, if you will, of that electron, but not the cost to you. And the cost to you of a nuclear electron is very different, because capacity factors are high, it hits the wire and comes to you. It doesn't need anything else. The cost to you of a solar electron is different, because at night, which happens almost every day,
It's true.
You have to
all
have
over
something.
The world, except for a few spots at the poles. Yeah.
And then you have long winters or summers, and so you have to have something else there, and that something is expensive because it's redundant. That reliability costs money, and that's what we're trying to do in this comparing electricity options study, is compare those costs. And it's not what you think. You might think, oh, natural gas wins. Well, it doesn't win. It has challenges. Everything does. This is the point. It's not a grand competition. Everything makes sense depending on where it is and your resources and your infrastructure. But nothing, we can't start legislating away options. I put a piece out in Fortune late last fall about that. Legislating away optionality is crazy. You have to use an EV. Why? You can't have a natural gas hookup. Why? Maybe it's a better option for me than these other things. And optionality in anything matters. Portfolios of anything, real estate, stock, pick your favorite portfolio. You need options, and that's what provides security and reliability. So it's very, very easy to try to make things binary and black and white and get all emotional about it, which plenty of people do. But if you start to kind
Myself
of,
included.
well, we all do, but if you start to parse away the emotions and get into the radical middle, that energy, economy, environmental place in the center there, you see the different trade-offs. Very important to understand them and then work on them together. No, enough of this false competition. It just doesn't help anything.
Interesting. I had no idea about your guys' project to understand the system cost. Let's dig in on that a little bit more.
Yeah.
What's going to be the outcome? Is there going to be a report released, or is this kind of a continuous process? What's the
Yeah.
timeline? Give us more
Yeah,
details. What can people
It's a
look for?
consortium. So we have several industry sponsors in the consortium. We would love more.
Sure.
I'd love to have a nuclear company in there. I'd love to have a solar and wind company in there. It matters to everybody. So it's a consortium. It is public in the sense that we publish the results from that in peer-reviewed literature and present it at conferences. So everything the Bureau does, again, we're at the University of Texas at Austin. I'm a endowed professor here. So we publish our stuff and it gets out there. The timelines will be staged. We have 3 stages in the initial project. We're in stage 2 now, and it's starting to come out. So I think it'll be a very important contribution to the conversations, and would love to have any companies listening join. There's 3 levels of membership, and the lower one is pretty, not that much, So you get in the room and you get to hear it and talk to the folks and talk to other companies and get rigorous about it.
Who should people reach out to if they want to get involved?
Oh, me. It's fine.
Okay.
We have Michael Young and Gershon Gulen are the principal investigators. One's a real senior economist and one's a senior scientist of the comparing electricity options. You can go to the Bureau's website under consortia and you'll see it, CEO. Click on it and there it is. But you can reach out to me and I can connect people.
Gotcha.
Yeah, I didn't mean this to be an advertisement for research.
No, not at all.
But it's really important.
But
this
it's
is so
relevant
important.
Research, and it's something that, like you said, everyone leans on LCOE as a metric. I even in preparation for this rewatched the first season of your Energy Switch series, right, where you've got the contrasting views, and the opposing nuclear view in the first episode immediately cited the Lazard report, which points to, anyone that's been in this conversation for a while understands that the Lazard report is radically inaccurate, meaning from a systems view. They use LCOE, and they say it in the second bullet of their presentation that they're making a bunch of assumptions and they're not including system level cost in this, and yet people and experts will cite it as evidence that, oh, well, renewables are cheap and nuclear is expensive. And so I commend you guys on putting the work in to dig into the details. Right.
Thank you. I think we will piss everyone off equally. And that's when you've kind of hit the sweet spot of compromise. And it's not like we're compromising the data or the science. It's just that none of these things are black and white.
Yeah. Well, let's dig into that a little bit, because I wanted to talk to you. I think you're an expert at communication and education, and being able to keep a level head and yet ask thought-provoking questions. And I think that we're focused on energy-dense fuels, oil, gas, nuclear. How can we use these things more to better human lives? And these can often be very polarizing topics. And so I would hope to gain some of your insight and help our audience be educated about how to have these conversations. How do you enter a room and disarm people with questions? Or I just think you're very effective at it. And on your Energy Switch panels, you do a good job of balancing views. So what advice do you have for people along that thread?
In terms of communicating or talking about the energy density space?
Let's start with communicating. Let's start with communicating, and then we can dive into the energy density, because I've got a lot of questions for you there too. So.
Yeah. Look, the older you get, you realize you really don't know much, and I'll be 64 this year, and I don't know much. I've studied things and learned and listened and traveled and seen it. I'm a see it kind of person. I learn better that way, or talk to people. there's just so much in this space. And so what comes with that, if you truly embrace it, is humility. And humility can be very humbling. You know, like,
Absolutely.
oh, I didn't know that. So if you enter a conversation that way, and sometimes it's hard. Look, we all bring our own biases for sure, and our own perspectives and our own knowledge. But if you enter the dialogue that way, pretty quickly everybody sees, okay, I'm not threatened. I feel safe in this dialogue. Let's talk about things, and I'll compromise and you compromise. We'll listen, and we don't have to agree on everything. But Aristotle is credited with saying it's the mark of an educated mind to be able to entertain a thought without accepting it. Entertain
Yes.
without acceptance. Now, I learned last week that it wasn't actually that Aristotle. That was a pretty heavy reduction of what Aristotle actually said. Darn it, I've been quoting that, but I'm going to stay with it. but anyway, so you listen and learn from one another, find out where everybody's passions lie, and then as much as you can use data. Again,
Yeah.
data doesn't work in emotional dialogues. You know, hey, Scott, I was raised in the Baptist church. Well, Mark, that's a stupid church. Why would you ever go to a Baptist church? You should
Yeah.
come to the Presbyterian church, or maybe you should come over here, and be a Muslim or a Hindu. And you're going, well, hold on, that's my religion. That's how I was raised. You can't call it stupid. And so, and I'm not saying science is religious, although it can have religious undertones when you start using terms like believer denier. These are terms intended to set up a dialogue that is not scientific.
Right.
Okay.
Yeah.
So we kind of put those dialogues into place and come back in and talk about our data and what we've learned and some of the interpretations of that, and try to go from being completely factual, which is important, to factually complete.
Right.
Factual completeness is hard. It means looking at lots of different sides of a problem. And we don't have all the facts. None of us do. So you have to get other input to that. And that's the communication of science, I think, is so fundamental. It takes a little bit of time. It's not sound bites, but it can be
Well, and
done.
especially, I think one of the biggest challenges is many people that are engaged in science view it as, oh, well, this is just objective. And, you start with a belief or a moral that you want to achieve, a goal that you want to achieve, but then use data to back up some of your objectives. But ultimately, and then just assume if you just tell the data, I see this in the nuclear industry all the time. If you just tell the data, just show the facts of how safe it is, just show how few deaths, then people will understand the story. But humans learn from stories, and often you need an accompanying story, right? Meaning, if you listen to any political or politicians speak about tragedies, they'll focus in on stories, or in any presidential debate or campaign rally, they tell stories about individuals. And I think the energy industry could do a better job of that. And I'll commend you, meaning all of the work that you do, all the movies, you focus in on specific characters, and you tell the story of how energy impacts their lives.
Mm-hmm. Storytelling is a huge part of communication. You have to make sure the story you're telling is told with love and truth, and you have to have both of those. Okay, so we hear a lot of loving stories that are only partially truthful and very emotional. And
Yeah.
you can see that story unfolding, but the rest of the story, as Paul Harvey used to say, a radio person way before your time probably, and he would say, and now the rest of the story. And so out it would come. And kind of the Columbo way of investigating, So the storytelling needs to be as complete as it can be and represent as many dialogues and perspectives in the story as is possible. When we made our film Switch On, we went to 5 or 6 countries and showed these stories and threaded them throughout. And then I had a couple friends of mine who are very good friends, smart people, and also very honest with me. And they watched the film and they said, it's okay But I don't know how many other people in the world that story in Nepal applies to, or that story in Colombia applies to. So lights go on and we have the unfolding globe and we show all the places where people are cooking with dung or wood or hay. And we show all the places in the world where, people don't have electricity at all. Oh, here's a story that affects a million or a billion people. Here's one that affects 2 billion people. Here's one that affects, and so that's powerful storytelling when you can use the data to help make it broadly representative.
I like that. I like that a lot. Well, let's pivot a little bit because I mean we like I said, oil and gas, nuclear, energy dense fuels, and we want to be, I certain we're obviously biased and we admit our biases. Want to be all for all types of energy, but we think that the right tool for the job has proven time and again that having reliable sources of fuels that you can use at any time are helpful. My question for you is, how have you seen this dialogue evolve over time? And do you think there's been a shifting perception from your experience in the acceptance of some of these fuels, specifically nuclear?
Yeah. When I gave my TED talk last year, I started with kale and cow.
I love that. That was a great intro.
And people were like, "Why are you doing that? It's right before lunch. I'm hungry." 1,100 students. Let's go eat. And the point being, they both have things that are good for you. And one's really dense and has a lot of kilocalories, and one's less dense but has vitamins and minerals. But we're not going to outlaw one or the other. Some people don't want to eat cow. Fine. Some people truly hate kale. I had probably 500 people write me and say, "I can't believe you said you like kale. Nobody likes kale. I don't believe you with anything anymore. I actually like kale. I don't mind. I don't love kale. I'd rather." But the point there was to take people into density, to think about density of food and then into energy. You say we like dense energy. I could say to you, Mark, why? You just all of a sudden like dense energy, or is it the things that dense energy does that you appreciate? That it is something that is there and has a high capacity, meaning it generates almost all the time from a power plant, not much waste. Is it that it's always on? I can use those electrons from a nuclear power plant all the time for the most part, unless they're replacing the fuel rods once a year or down for service for other reasons, which is very rare. Is it that you feel that it's affordable once it's built? The actual electron, the kilowatt hour out of a nuclear power plant costs us essentially nothing because the fuel is essentially very affordable once the plant's built. What are the reasons? And so you start describing reliability and affordability and availability. Is it that you think with a small modular reactor, I can put it in communities now where I couldn't before? So I could take a 100 megawatt facility and put it underground safely, even in an African set of villages, and have it be the baseload source and supplement and partner it with solar, perhaps in Africa. And so what is it about density that's good? And the driver of that is really physics. Physics is what
Yes.
drives these things. We have been leaving less dense energy, which the first energy ever was the sun. It grew hay, and we put that in our vehicles, an oxen or a mule, and that hauled their own fuel around, their food in their own cart to wherever they were going, and then they ate it. And so that was the first energy. And we started going through the motion of wind for windmills to lift water hundreds of years ago. And the motion of water for mills hundreds of years ago. So we used the motion and we figured out how to make a gear, etc. So we've been going from that form of energy, and then coal was discovered. And this changed the world. Coal was a dense form of wood that nature had densified, and we could burn it and get more heat from it. It would last longer. Okay. That changed the world. All of a sudden, we didn't need a tree for every person. We could do more things. And so we have been naturally going away from carbon-based fuels, hay and wood. Bioenergy is the oldest form of energy, and it is carbon.
Yep.
When you burn it, it makes CO2, period. You know? And to convert these carbohydrates to hydrocarbons, which we do in conversion facilities, or directly burning them, takes energy. It's not a zero emissions process. Let's be honest here. So, but as you leave that and come into coal, which is carbon, and then hydrocarbons, which are hydrogen and carbon complex molecules, to methane, CH4, which is 4 hydrogens, or propane or butane, different carbon hydrogen mixes, pentane. And then hydrogen. Hydrogen is no carbon. It's a very dense form of energy. People confuse that with, oh, it's element number 1. H2 doesn't float around anywhere. It does. It actually does form naturally in some places, but you have to mostly make it from splitting a water molecule, H2O, or splitting the methane molecule, CH4. That's where you get hydrogen. So that takes energy. It takes energy. But hydrogen itself is then available, and it's a wonderfully versatile fuel. You can burn it. I mean, the worst example, the terrible one, is the Hindenburg. It was a hydrogen dirigible. It burned very well, tragically.
Tragically.
Hydrogen is also an electron carrier in a sense. So a fuel cell is essentially using hydrogen to carry electrons, and like a battery, so there's no emissions from that tailpipe. So you hear the hydrogen economy, we've heard it for years, we're moving towards that kind of a system. And then here's nuclear. And nuclear isn't carbon and hydrogen, it's radioactive elements. It's uranium and thorium mostly that are used because they are radioactive and they release heat as they decay. And that if you can control the release of that heat, I'm talking about fission now, splitting things, not colliding them. If you can control the release of that heat, I can boil water, make steam, turn a turbine, and run a generator. It's the exact same power plant stack as burning coal to boil water, make steam, turn a turbine, run a generator, just a different source of heat. But it's very dense. So
that's awesome.
The analogy for the density that I use, and you might have heard this, is you stuff these little fuel rods with these uranium pellets. They look kind of like deer feed or something. They're maybe a centimeter tall, half a centimeter wide, cylindrical. So that little pellet, think a centimeter by half a centimeter, and you put a bunch in there. But one of those pellets contains enough energy, its energy density, to drive a vehicle, a car, from New York to LA to Dallas, back to Dallas. One pellet. And so now I can't, people go, oh, cool, let's put the pellet in my car. No, we're not quite there yet. It's the energy equivalent. But that's kind of and by the way, that car running on gasoline is very dense.
Yeah.
It would take.
And it's even more dense. Yeah, right. It would take several times refueling.
Yeah, right.
Maybe the volume of the car.
Let's call it, what is that, about 5,000 miles probably. Let's make it 4,000, make the math easy. Divide by 20, 200 gallons of gasoline at 20 miles per gallon. 200 gallons. A gallon of gasoline weighs about 6 pounds. So that's 1,200 pounds of gasoline, which is a really dense fuel, or one pellet.
Yeah.
And that's why density matters. Here's the environmental reason. The denser things are, the less impact on the environment.
It's true.
Just full stop. You don't have to mine as much. You don't have to manufacture as much. The power plant itself can be smaller. The heat is contained.
Take up less land.
So land, water, air, nuclear has no emissions at the power plant. There's some in the mining and moving it, but not much. So when you think of environmental impact, think of the 4 pillars of the environment. The atmosphere, the air, those are different. They blend, but those are different. The land and the water, big pillars. We have to protect them all. They're all critical for human life and all life on Earth. protecting them all isn't easy. There are trade-offs, candidly, between these different things. You can try to go do all water protection and you will hurt some other things. You can try to do all atmosphere, all climate all day. You will hurt other things. And that's hard for people who have their deepest passions embedded in climate change and its threats. That's hard for them to hear because they hear, well, you don't believe in climate change and it's going to be terrible. Not true. I just think there's ways to do it that are going to also not harm the land, the air, and the water, and also lift people out of poverty. And that's the dual challenge. That's the great dual challenge, human flourishing and environmental protection. Dual challenge, human flourishing, environmental protection. We've got to do both.
So asking maybe a challenging question, why, and we're totally aligned on this, and so I'm just curious on your perspective that.
Well, that's no good. That's terrible. We can't be aligned.
Sorry, well, maybe not on my question, but we agree that using the most energy dense fuels is the best for the environment. Then why do a lot of, I'll put in air quotes, environmental organizations like Sierra Club, Rocky Mountain Defense Council, et cetera, oppose nuclear energy? I still can't figure this out.
Yeah.
I mean, I've heard a lot of theories from the nuclear industry about, it's originally funded from fossil fuels and it's a legacy of the environmental movement in the 70s. And, there's lots of things to point towards it, but I just view it as irrational.
Yeah. You're trying to be logical.
Okay.
That's your problem.
Well, maybe that's what we disagree on. I think that we could be logical about it. And perhaps you think we needed to be emotional about it.
If you're going to change hearts and minds, you have to see the emotional side. Back to our communication.
Right.
I don't think you should have grown up a Baptist, Mark. Okay.
Fair.
Okay, that's not going to win the day.
Yeah.
You have to get into the emotional reasons why people are fearful of things. And look, there's not a single answer. Some people, let's be completely honest, you hear about the conflicts of getting funding from big oil or the conflicts of getting funding from big tech or from big ag. Well, there's conflicts from getting funding from big NGO.
Yeah.
All right. They literally, there was a piece I read recently from, I think it was Robert Bryce, on the billionaires behind some of these things. And they literally are excessively well funded to oppose things like nuclear. Why is the question you're asking, but that's the what. So to keep getting that funding, you have to oppose this thing. There's that piece. Let's just set that aside for now, but it's a piece of it. For some, there are other pieces to it though. Read Michael Schellenberger's book. Michael was on Energy Switch, wrote a great book called Apocalypse Never. And he explained a lot of the structural genesis of the climate fear movement. Okay, because he was in the room helping to create it.
Yeah.
And what like I said, I'm older, so I grew up in elementary and school. I would dive, we would have to get under desks in school for nuclear drills. I grew up being fearful of nuclear. I was trained to be. Kids today growing up being trained to be scared of climate change. There are real reasons to be thoughtful about nuclear, and there are real reasons to be thoughtful about climate. So it's not this, oh, you're being trained for something stupid thing. No, it's important. Both of them are. But the fear is what drives our emotional response. So the older set, I'm in it, are trained to be scared of nuclear. And so they hear this word and they think they conflate nuclear warfare with nuclear power, which are different things. They think about proliferation of weapons and who gets them in their hands. It's just it's a set of thinking that has been trained into people of a certain generation, and it's very real. We do have to protect those things. We can't let, fission products that have plutonium in them get into the wrong hands to be acted on and turned into nuclear weapons or dirty bombs. This has to happen carefully. Now, as you come down the generations, less and less fear about nuclear, more and more about the environment originally, and then climate. Climate became the only environmental thing for some. And And so I'm hopeful that this generation, and I talk to a lot of students, they're not fearful of nuclear. This generation being, I have kids ranging from 33 to 22. They're not scared of nuclear. In fact, they see it as one of the solutions. That's terrific. I'm ready to hand over the reins to the next generation to take on the challenge of no emissions, dense energy, power for all, affordable, reliable. Knock your socks off. Why do some, your question was, say solar and wind is the only solution? The reason is in part because there are no emissions from that source. Climate drives. Climate is the existential threat. It drives. There's no emissions from that source. So that is the only way to get no emissions energy. Why would you go do something risky like nuclear when you can just do solar and wind and batteries? And if you don't believe that, you're some kind of a denier, back to the religious frame. What's not being put into that dialogue is the environmental impacts of that full stack.
Yeah.
Of scaling up solar and wind and batteries to a point where they could potentially address a significant piece of the electricity part of our energy demands. That's going to take a tremendous amount of infrastructure, a tremendous amount of mining and cost to that mining.
Yeah.
Processing of those materials, which is done 80% in China. So there's an
And it's
energy
going to have huge environmental impact globally.
Yes, but not as much on the atmosphere for sure. But on the land, the air, and the water, it's a whole different scale than we've ever done. And then there's energy security because China processes it. Brilliant China, Belt and Roads invested in buying all the resources and they ship them to China on diesel-fired barges, process it, take the metals, and then create the products and send them around. And you got to manufacture all these things. And then here's the kicker: when they wear out, what do we do with it? The batteries and the panels and the turbines, which there will be an inordinate number of, get dumped into landfills. We don't reprocess and recycle them. Very small. We can, but it's expensive. It's really expensive. It's much cheaper to just do it new. That's why most recycling doesn't happen. So we haven't thought about the life cycle impacts yet. It's starting to happen. People are realizing it now. And then where it's done, we don't realize the sun is a resource and the wind is a resource. It's sunny in some places and not in others, and it's windy and not in others. So you got to do it there and move it. I'll give you batteries. Here's a great example. One of the largest lithium deposits in the United States is in Maine. It's in hard rocks, in spodumene. And the Maine legislature voted essentially no mining. The governor vetoed it, and they overrode the veto 35-0. To essentially no mining of lithium. And then the same legislature is passing an EV only law. So Maine wants their electric vehicles.
Feels hypocritical, doesn't it? That's very strange.
It feels uneducated. Okay, and hypocritical is a strong word. It is, I guess, but it's maybe we don't know that the EVs have to have the lithium. Not every place has lithium. Maine, you could mine it and help not only make your own batteries, but batteries for other people. This stuff can't all happen in Texas. Just do it in Texas and send it to us, and we'll be green. Okay, this is not a good strategy for environmental protection, especially the atmosphere. So just make it in China, burn all the coal because it's cheap, and send it to us, and we'll be green. This is not a zero emission strategy. It's a goofball thing.
I love it, Scott. There's a lot that we could unpack there, and I could talk to for an hour, 6 hours, just about all of the topics that you just spanned. But I'll summarize back what I heard. Some of the environmental movement sold fear. There's a disparity in kind of what people are most fearful of and what drives them. And so potentially a solution could be generate a new narrative or change the dialogue to inspire stronger emotions than what people currently are driven by, both either fear, but hopefully hope, or show the promise of a better future. In my mind, is a more empowering way to motivate people, and people can disagree on what is more motivating, fear or bettering your life. But I want to circle back, and I think we'll be coming up on kind of our time.
And let me just quickly, that was a great summary in many ways. I rambled around with a couple of stories, but let me say again, it's not binary. Solar and wind have places in the world. They are needed, distributed, first solar, first energy, end of mile, even some industrial scale things. Nuclear has a remarkable role to play. So does methane, natural gas, and hydrogen. These things partner together for reliable, affordable energy. That's the hopeful thing. Let's not say it's either that
Yes.
or that. Here's the place for both. They make the system better. And when I have a healthier system, my economy runs better. And guess what? I have money to invest in the environment. And this is the kicker. It goes in that order. Energy, economy, environment. Do it again. Energy, healthy economy, invest in the environment. It goes in that order. The worst environments on the planet are where it's poor. They simply can't afford to clean it up. And so that's the hope, is let's partner these things together. It's not going to be everything you were taught or thought you wanted, anybody, but we have these roles to play. And that's where it gets solved.
I love that. You know, when we spoke previously, the last question that I asked you was, how do we, or what scares you most about energy? And you responded, a world without energy scares you. And I had the opportunity to listen in on a panel discussion back in November at a conference about the war in Ukraine. And one of the panelists was the energy minister there, who cited their current living conditions and how they were rapidly deteriorating, how their energy infrastructure was being specifically targeted and taken out, and how that was impacting the lives of the people in the country. And you know, when I was thinking about this interview, there was kind of like a materialization of the thing that scares you most. Is like you're living in this society that is blossoming and frolicking, and then suddenly your energy infrastructure is getting taken out, which is terrible. And so my question to you is going to be, you know, how do we avoid that moving forward? But I think with your previous response, you did a great job kind of answering it. We need everything. And if we focus on building more energy first, then when the economy will blossom, then we can protect the environment. But also just curious on your thoughts there, you know.
Well, it shows that energy can be weaponized, and economically as well as actually physically, and it is being weaponized in the Ukraine, both of those. We modern societies who are completely dependent on energy and have no idea how much we depend on it because we are spoiled. And I don't mean that in a spoiled child way. We're just spoiled by access to affordable energy. We've never grown up without it. When it goes away, we get upset and we get scared and we get angry. So we have to have systems that are reliable that way. I would add a second fear, and here it is. I have a great fear that we have promoted this concept that we can change from something to something else so quickly. And it's not even the right direction necessarily, but this transition is this quick, rapid change, and therefore we don't need to invest in oil and gas. So this will make people angry with me, but we have to have so much oil and gas and natural gas for a long time. These reservoirs are declining in production, 70% over 20 years. Just to replace what's there is going to take a lot of investment in infrastructure and exploration, just to replace what's there. If the world begins to suffer from the economic ramifications of a lack of oil and gas, things get really ugly. It's not my solar panel supply chains have been impacted. This is war. The world goes to war over oil and natural gas when it goes away. So we have to invest in that because we need it. They do things other things can't do, not exclusively, as we've said, but we have to also protect the security of that global system, which we all depend on. Now, I have a great fear right now that intelligent people are believing we can just not invest anymore in these things. And that puts the control of it into The Russian oil companies and the Middle Eastern oil companies, OPEC oil companies. Just look who the largest producers are. It's not Exxon, Chevron, Shell, BP. It's Rosneft. It's Aramco. These are the largest producers by a lot. You put it all in their hands, crazy talk.
Yeah. Okay, well, I like to leave folks on an optimistic note. So
that's
a
not
wonderful, wonderful contrast. So I'm going to challenge you to say, how do we do that? How do we motivate people to realize that these things are important? And I mean, I think the work that you're doing is phenomenal, and so I know that you're doing your part. But give us advice and paint a picture for us on how we can change the future to be better.
Here's what I would do. I've been suggesting to my audiences now. I would challenge everybody listening to go out and give one talk this year to 20 people. One talk on energy. And I am going to put my slides, animated, data rich, with my narrative under them and text on the website for free. And you can grab those and select your group and go talk to a school or a church group or a scout troop or a civic group. 20 people. Give one talk. It'll be hard. But everybody listening to this knows more about energy than most people in the world. Mark, if we start to do that, let's say you have, I know, 1 million listeners. So that would be 20 million people. But if you have 500 listeners, that's 10,000 people directly being spoken with and having an engagement, a civil dialogue. That's how we do this, is one mind at a time, communicating. And I will help. Send me an email when you've done it. Your listeners, send me an email, say, Scott, I did it. It was terrible, but I'm going to be better the second time. And thanks for the slides.
That's one of the best recommendations, and that I've ever heard. That's awesome. Tell you what, I'll commit to giving 5 to 10 talks. How's that?
Boom. I love it. And I have my deck here. I've pulled down all the latest data. So I wanted to put the most current data in, and it'll be on the Switch Energy website. We'll highlight it right at the beginning. Here's the deck, because everybody's asking for it now as I challenge people to do this.
Yeah, absolutely.
Okay.
Well, Scott Tinker, we really appreciate your time. Thanks so much for being a guest.
Yeah, you bet. Glad to be here. And thanks for all you're doing.